Meta secures a $21 billion AI cloud infrastructure deal with CoreWeave. Amazon's AWS hits a $15 billion AI revenue run rate, and Meta unveils Muse Spark, featuring a brand new contemplating mode. If you're trying to keep up with the absolute whiplash of the AI industry, you already know things move fast, which is why you are listening to inuku.com, AI news you can use, your daily dose of AI know-how. We are officially at the point where a single AI model release can autonomously chain together zero-day exploits, tanking Wall Street software stocks overnight, while entirely separate AI agents are actively being handed the keys to billion-dollar enterprise procurement budgets. To understand where we are going, we need to dive straight into this massive $21 billion cloud deal from Meta. Now, Meta has effectively infinite capital. They literally lay their own fiber optic cables across the floor of the Atlantic Ocean. So why on earth are they suddenly locking themselves into a massive multi-year contract to rent server space from a specialized cloud provider like CoreWeave through 2032? It might feel like a strategic failure. Why not just buy the land, pour the concrete, and own the infrastructure outright? But it is not a failure at all. It is a brutal concession to the laws of physics. You really have to look at the thermal output and the energy density of the hardware they are deploying. Right now, this deal gets Meta early access to NVIDIA's new Vera Rubin platform. We are talking about chips that draw so much power, well over 1,000 watts per processor, that traditional air cooling in a massive warehouse simply does not work anymore. It would literally melt. You need highly specialized direct-to-chip liquid cooling infrastructure, specialized manifolds, and more importantly, you need to be physically located on a local power grid that can actually sustain a multi-gigawatt draw without causing brownouts in the surrounding county. Meta has the money to buy the chips, but they cannot get the permits to plug them in fast enough. CoreWeave is an infrastructure specialist. They already have the municipal permits secured, the concrete poured, and the substations built. In this AI arms race, capital is abundant, but time and electricity are scarce. So, when you are trying to train a model with 1 trillion parameters, you gladly pay a premium to whoever already has the power cables laid. That infrastructure reality makes the AWS numbers highly illuminating. Amazon's cloud division just reported an AI revenue run rate of $15 billion. It is easy to wonder if that is real cash from external customers or if they are just shuffling cloud credits around to internal startups. But the telemetry on this is concrete. It is real revenue. What is critical to understand is how Amazon is actually achieving that margin. Yes, they host expensive NVIDIA hardware, but the real margin driver is their custom in-house silicon. Their Trainium and Inferentia chips have doubled to a $20 billion run rate on their own. If the Vera Rubin chips are the gold standard, why run workloads on Amazon's chips? It fundamentally comes down to workload specificity. A frontier GPU is a massive generalized beast designed for the incredibly complex math of training models. But once a model is trained and you just need to run it, what we call inference, using a massive GPU is like using a sledgehammer to drive a thumbtack. Amazon's Inferentia chips are optimized purely for throughput at the inference layer. They consume less power, generate less heat, and are drastically cheaper to run. The hardware stack is fragmenting based on the specific job, which brings us to heterogeneous infrastructure, perfectly illustrated by the Intel and Google partnership. They are deploying Intel's new Xeon 6 processors coupled with custom ASIC IPUs. To understand an IPU, or infrastructure processing unit, look at network traffic. When a data center orchestrates a training run across 100,000 chips, there is a staggering amount of data moving horizontally across server racks. This east-west traffic requires network routing, encryption, load balancing, and security protocols. Historically, the central CPU handled all of that, burning clock cycles playing traffic cop instead of feeding data to AI chips. Up to 30% of computing power can get eaten up just managing this flow. An ASIC, an application-specific integrated circuit, is physically hardwired to do one mathematical task flawlessly. By deploying an ASIC IPU, Google and Intel offload network routing to a dedicated chip, ensuring the CPU and GPU operate at 100% utilization for actual AI orchestration. If we swing to the opposite end of the spectrum, there are massive investments in hardware that will never sit in a server rack. Sci-Fi just raised $400 million to push alternative processor architectures, and Qualcomm acquired Exostellar for edge workload management. If the cloud is so optimized, why pour millions into edge AI running locally on phones? We are hitting a thermal ceiling, but edge AI is driven by latency, privacy, and memory bandwidth. If you want a real-time AI assistant, you cannot afford the latency of sending data to a server and waiting 3 seconds for a response. Furthermore, streaming constant telemetry to the cloud is a privacy nightmare. Exostellar's technology acts as a dynamic router, allowing the operating system to intelligently decide, in real time, which parts of a task can be processed locally on the low-power mobile chip and which require the cloud. While compressing models for the edge, the cloud models are evolving rapidly. Meta came roaring back into the frontier race with Muse Spark, a fully multimodal reasoning model. The defining feature is contemplating mode. For years, models operated on autoregressive generation, thinking linearly, word by word like autocomplete. Contemplating mode uses test-time compute. Instead of blurting the first answer, it pauses and runs internal simulations. It spawns internal agents to draft a solution, critique it for logical flaws, try different mathematical approaches, and debate. They score each other's outputs and prune incorrect branches of logic before presenting a single word. Meta is embedding this proprietary, highly capable reasoning engine directly into WhatsApp and Instagram, pushing it to billions of users. This aggressive deployment highlights the philosophical civil war regarding capability governance. Anthropic developed a model called Claude Mythos that is a monster at autonomous cybersecurity. It can map a network, identify undocumented vulnerabilities, and chain together complex Linux kernel exploits without human intervention. That level of offensive capability is exactly why Anthropic locked it down, restricting access to deeply vetted agencies. But simply knowing it existed caused U.S. software stocks to plummet. Wall Street realized the protective moats surrounding legacy software are fundamentally gone. Meanwhile, ZAI released GLM 5.1 as fully open source, architected for autonomous work. Their philosophy is that the only way to build defenses against autonomous AI is to democratize access, the good guy with a gun argument. The developer community is caught in this crossfire. OpenAI's Codex recently hit 3 million weekly active users relying on AI to do their jobs. The paradigm is shifting violently from passive suggestion to autonomous execution, the agentic software revolution. An AI librarian tells you how to dispute a medical bill. An agentic AI autonomously logs into your insurance portal, solves the CAPTCHA, submits the appeal, and monitors your inbox for 3 weeks until you get a refund. Building the back-end memory pipeline for that is a nightmare, requiring massive vector databases to store context. That is why Anthropic released the Claude Managed Agents API. They host the vector databases and manage state retention, allowing companies to deploy enterprise-grade agents in 48 hours instead of 6 months. Perplexity is capitalizing on this, crossing a $450 million revenue threshold with domain-specific agents like a tax agent fine-tuned purely on tax law compliance. They launched the $1 Billion Build initiative, funding founders building unicorn companies using 0 human employees, just a swarm of AI agents. This forces us to look at vibe coding, the end of syntax. You don't write code. You use natural language to tell the AI to build a logistics dashboard, and it handles the computer science. Accenture just invested in Replit to become architects of agentic systems. Cursor's visual design mode lets you drag a button across a screen, and the AI rewrites thousands of lines of code in the background in real time. These abstraction layers are crashing into consumer hardware. The Samsung Galaxy S26 Ultra bakes Gemini directly into the operating system. You photograph a crumpled receipt, and the AI autonomously reconstructs the geometry, removes creases, and outputs a perfect digital document. Its audio eraser isolates human speech from sirens in real time. On macOS, tools like Clicky live on your screen and proactively offer macros if you struggle to format a spreadsheet. Google's AI Edge Eloquent edits your messy speech into polished paragraphs in real time. This breaks how we benchmark AI. The old word error rate metric penalizes models that fix your grammar because the literal words don't match, even though the AI perfectly delivered your intent. But what happens when an agent misunderstands context? A 99% accuracy rate sounds great, but at a billion daily operations, that is 10 million catastrophic, unforced errors every single day. Gartner projects 25% of enterprise AI apps will suffer security incidents simply because the AI gets confused. The industry is building strict cages using the Model Context Protocol, or MCP. It acts as a digital bouncer, assigning the AI a cryptographic key that only unlocks pre-approved databases. If an agent wanders into the HR server, the connection is rejected at the protocol layer. MCP solves access, but not hallucination. Google AI overviews are roughly 90% accurate, meaning they present objectively false information tens of millions of times an hour. Models are probabilistic engines trained on internet data, incapable of distinguishing verified facts from sarcastic Reddit threads. In high-stakes environments, tolerance is zero. The CIA deployed Ghost Murmur to locate a downed airman in Iran. The chain of custody for every fact must be flawless. Local governments like San Francisco are mandating human-in-the-loop oversight to shield the city from legal liability if an AI hallucinates a zoning code. Tech giants are trying to reshape society before regulators do. OpenAI advocated for a 4-day work week, stating that efficiency gains from agentic AI are so massive that workers should get their time back. Meanwhile, the sharpest money, like the $100 million zero-shot VC fund started by OpenAI alumni, is ignoring consumer hype to fund heavy industry. They back Worktrace AI to analyze workflow bottlenecks and Foundry Robotics to optimize factory floors. BMO established a dedicated institute for AI and quantum, preparing hybrid models that combine AI's pattern recognition with quantum computing's probability calculations. Canva is acquiring agentic AI to create a creative OS that autonomously designs, writes, and deploys entire marketing campaigns. HeyGen's Avatar Vi completely solves identity drift in synthetic video, using a 15-second baseline recording to mathematically lock your microexpressions so your face never mutates. In public safety, Canada integrated deep learning AI into traditional physics engines, making their 6-day weather forecast as accurate as their previous 5-day forecast, granting a massive leap in predictability. This ultimately leads to unprecedented monetization. OpenAI projects $100 billion in ad revenue by 2030. AI native interfaces and agentic voice systems are about to become the single most valuable monetization surfaces in history. If you rely entirely on an AI agent to architect your software stack or buy a car, the ability for a brand to pay to insert their product into that AI's recommendation engine is worth a fortune. Before we get into the final takeaways, just a reminder that you can find more insights like this at enuku.com to help you master these massive technological shifts. Let's summarize the key actionable insights. The hardware infrastructure is rapidly splitting between massive liquid-cooled training clusters and highly optimized inference edge computing. Frontier models are pushing past passive text generation into code, contemplating reasoning and autonomous cybersecurity, triggering a massive debate over open-source safety versus strict capability lockdowns. The software world is embracing agentic execution, where you direct the vibe and the AI writes the syntax. But this demands absolute architectural safety nets like the Model Context Protocol to prevent enterprise-level disasters. Finally, as AI augments everything from creative design to global weather forecasting, the interfaces managing these agents are positioning themselves as the ultimate commercial gatekeepers of the future. And that's your daily dose of AI know-how from enuku.com, AI news you can use. The biggest takeaway today is to ask yourself, as massive corporate algorithms begin paying billions of dollars to market products directly to our personal autonomous agents, what exactly happens to the human consumer in that loop? Are we the masters of the agents, or just the wallets funding their conversations? Stay smart out there.